So the first one, if you distribute your A, we get what?
3
Plus.
plus 7A.
Okay, second one, you get?
-2 into 4 plus 12A squared plus 2A.
Okay, and the last one?
4x to the 5th y minus 8x to the 4th y squared.
Okay. So that's what we get when we multiply these. Today we are going to start factoring, which is going in reverse. If we start with this, is there any way to figure out what we were originally multiplying together? So factoring is rewriting a polynomial as a product. Going backwards and figuring out what was originally being multiplied together. So if I gave you something like 4a squared plus 8a, and we had to factor it, it's like looking at this and saying, okay, let's start with the coefficient. What number can divide both 4 and 8? 2 or 4. We'll go with the bigger. So 4 divides both of them. Then you look at your variables. We have 2 a's and 1a. You have to take out the smallest number. Okay, I can't take out both of them because I don't have 2 a's here to take out. So if I took out 1, when you go in reverse, it's just like dividing. If I said, what is 4a squared divided by 4a? That's multiplying. If I'm dividing them,
So it'd be 2a.
4.
the 4's will cancel. A squared divided by a is a. Okay, if I had 8a divided by 4a, the a's cancel, and that's 2. If you multiply this back out, we get the 4a squared plus 8a. So you can always check it just by seeing, okay, if I distribute this again, do I get what I started with? So we are working in reverse like that. Some things can't be factored, and in that case, we call it prime. So if there's something and they don't have anything in common, if we can't work anything, we say prime. So there are a lot of different approaches we will learn for this. This is just our first day, and we are going to be spending quite a bit of time on it. The approach you will take will depend on the polynomial we have, whether it's a binomial, which means by 2 terms, or a trinomial, which means 3 terms. So we have different approaches based on the number of terms. But today we're going to start with this first step of factoring, no matter what I give you, which is the GCF, greatest common factor. What we did here, what divides both of them? And that will be our starting point on any problem that I give you to factor. So, if I were to look at this one, 3x plus 12, how many terms do we have? 2. So I'm looking for anything that would divide both of those terms. So they're both divisible by 3. That means I am factoring out a 3. Factoring out is like dividing. So if you take 3x divided by 3, you just get x. If you take 12 and divide it by 3, you get 4. So it's 3 parentheses x plus 4. How can you check yourself?
Because if you multiply it, you should get
If you multiply it, you should get the original problem back. 3 times x is 3x plus 12. So you can always easily check these just by multiplying it back out. All right. Let's look at number 2. So we have 2 terms again. What can divide both of them? 7. So when you factor it out, it doesn't go away. We have to write that 7 down. And then it's just like dividing. What is 7y divided by 7? Minus. What is 7 divided by 7? So it's 7 times y minus 1. Can you do 36 divided by 8? It doesn't work out evenly, so we have to go smaller.
Can you do 4?
4 would work. Okay. What is 8m divided by 4? 2m. What is 36n divided by 4? 9n. And I couldn't take out a variable because they don't have anything in common. One has m, the other has n. They're not the same. If I look at number 4, can I take out any variables? No, because they don't match. So number-wise, what could we take out? All right. So 5x divided by 5 would give me x. 30y divided by 5 is 6y. All right, are we doing okay with this? Okay, I'm going to start jumping around a little bit. Let's go to problem 7. When you look at this, number-wise, I have 21 and 3. What do they have in common?
3 and the D.
3, and they both have a D, so we can factor that out. So factoring is like dividing. What is 21 divided by 3? We have a C, and those D's cancel, so it's 7C. Minus, what is 3D divided by 3D? 1. Anything divided by itself is 1. Okay. Let's look at number 9. 15 and 30, we could take out 15, and then they both have an A, and they both have a B. So if we factor that out, 15a squared b divided by 15ab. The 15's dropped, the b's dropped, and we are left with 1a. Okay, this term, 30 divided by 15 is 2. The a's cancel, the b's cancel, so those are gone. I want you guys to try a few. Problem 6, what could you take out of both? A 4 and y. Okay, so like dividing, you don't necessarily have to write that step, but if it helps you, do it. So the 4's cancel. Y squared divided by y, you subtract those exponents. 2 minus 1 is 1. Minus 24 divided by 4 is 6, and those y's drop. It looks like we did pretty well on that one. Yeah. Number 8, 14 and 18. They're both divisible by 2. What variables do they have in common? H. All right, 14 divided by 2 is 7. The h's cancel, so we just have g. 18 divided by 2 is 9. H's cancel. Right, and number 10, what number do they have in common? 8. What about variables?
I don't know, I did 4. Whoopsie.
Yeah, so 4 works, but it's not the biggest thing. We want to go as big as we can on those. So 16 divided by 8 is 2. B's cancel, we have a C left. 24 divided by 8 is 3, and both the B and the C cancel. Are we doing okay on those? Let's keep practicing. What about number 13? 5 and 13, does any number go into both? No. Do they have the same variable that we can take out? So if we can't factor it, what do we write? Prime. Remember at the beginning we said anything that cannot be factored is called prime. All right. Now I want to go into some that have 3 terms. So we'll do a few of these and wrap up for today. If I look at 15, now I have 3 different terms. So start with your numbers, 2, 2, and 4. So we can take out 2. Look at your variables. What do they both have? So it's like dividing each of these by 2xy. So in the first one, the 2's drop, the y's drop, x squared divided by x is x. Minus the second one, 2 drop, x's drop, and we have y. Last one, x and y both cancel, 4 divided by 2 is 2. So 3 terms, it's the same thing, but you have to look at what all 3 have in common. And just like before, if I want to check myself, what do we have to do? Multiply it out. Okay, let's look at 18. Right. Numbers 12, 36, and 6. Okay, let's look at our A's. They both have A and B. So one has 5, one has 4, and one has 2. You take out the smallest number, so that would be 2. With our B's, we have B squared, B to the third, and B squared. So we could take out B squared. So 12 divided by 6 is 2. With my A's, you subtract exponents. So 5 minus 2 is 3, and B squared cancel. Minus 36 divided by 6 is 6. With my A's, 4 minus 2 is 2. With my B's, 3 minus 2 is 1. Minus, in the last one, everything cancels. So what do we put? 1. Do we need more practice with this? So let me